And we are live in 3, 2, 1. Hello, my dear students. It's been a lot of time, and I'm here. At the same time, I want to take this time to apologize because of the long delay. So the last video which I uploaded was, I guess, 6 days ago. So when this video is uploaded, that will make this day the 7th day. So what have I been doing and what kept me from uploading a video? So let me just tell you. Well, the last week had been very much busy. There was school work. I had to make report card. I had to make the progress report for my students, so that had to be done, and that had to be taken care. So that consumed some days of my week. And then at the initial days, because the previous video was uploaded maybe on the previous Sunday, so what did I do on Monday, on Tuesdays and Wednesdays? I was getting ready to upload, but to tell you the truth, my dear students, sometimes it's not that easy again. Like, we are all human beings, and then we are very emotional sometimes, and I come out and then I present myself, and I'm speaking to the camera right now, and it's being recorded. But honestly speaking, this also takes a kind of a energy to be speaking to the camera. I don't have this experience of speaking to the camera, and then I have not been doing this. This is my first shot and my first experience recording myself, and at the same time speaking in this platform of YouTube. But as you all know, that it requires a lot of commitment and a lot of energy to do this. So sometimes the energy is quite low. Okay, so because of which I do try to record, but then I don't know, sometimes I see the recording and I'm not satisfied with the way I record. So sometimes I do delete, and that also happened just in the past week. So twice I think I stood up in the same place, wearing the same t-shirt, polo shirt, and holding the same marker, and every gear is same board. Question also here, written here. This has been there for nearly a week. Okay, it's been written here for 5-6 days. So this is how it is, my dear students. This is the truth. Okay, this is the truth of well, I don't know whether it is correct for me to say every YouTuber, but it's almost like I'm very near. I can say that that this is what every YouTuber goes through in some of their videos, in some of their phases of becoming a YouTuber. Okay, so that's what happened to me also. Somehow, to speak and to record myself, I feel like there is a certain level of peace and a certain level of confidence that I require, and sometimes I lack that. Okay, you may I don't know how confident I look, and at the same time how well I am presenting myself, but then this is all from God, and I want to take this platform and I want to take this opportunity to thank God, because without God, okay, this is impossible. This is impossible. And my dear students, believe me, okay, believe me, I am not here to preach, but at the same time I do acknowledge God. And so without God, we are nothing. We are created by God, and we are His most precious creation. So we are surrounded by a vast amount of energy, and it is only natural that sometimes we mix around with some bad energy, and then if we mix around with some bad energy, okay, we become, okay, not like ourselves. And so things are like that. Okay, not every day is easy, not every day we are ourselves, but some days, okay, some days, like I can say proudly today that yes, I am in my zone, and I can, and that's why I'm thankful to God that I can speak to you right now, and and I'm like, I have that energy in me, the vibe in me, that the radiance is there, I can say. And so I want this energy to be with me, and I know I can have this. Okay, I know I can have this, and this is all possible because of Almighty God. So my dear students, there is nothing which is impossible with our God. So keep your faith in God, believe in God, and do your work. Okay, but in every success and in every phase of your life, acknowledge God. If you are feeling down, pray to God. If you are feeling happy and excited, praise God. So here I am, okay, a mere mortal, a mere person, okay, just doing something which I like, which is to teach my dear students, okay. And all of you are my dear students, all of you are my dear students. You are very close to my heart. So I take this time and I want to inculcate, and I want to give you, and I want to help you through this medium which I know, okay, and which I'm undertaking. But at the same time, I would like to appeal to you, my dear students, that I am a newbie and I don't know, okay. I lack so many so many ethics in this online social media experience, but I'm learning. So please bear with me. And then at the same time, if you find this useful, if you find these videos useful, and if you still choose to learn from me, then I'm most grateful and thankful to you for learning from me. And at the same time, I will also encourage you to like forward this, okay, to suggest and to recommend to your friends who you feel will find this useful, find these videos useful, just like you found it useful. So with this note, let me not take any more time, because I feel like I feel good, and at the same time I also feel that you have also absorbed some of the positive energy which is being radiated from here. So on this positive note, I welcome you all, my dear students, to this channel Classroom. My name is Penatang Paton, and together we learn. So I've been saying this phrase for a long period of time, and you know, on days like that, I feel that this is truly the way it should be said. So thank you all for tuning in, and let's go and do this question, which has been written here for roughly 6 days. Okay, I even wonder whether I can erase this, because the ink gets hardened after some time. So let's read this question and let's solve this question together. So question number 15. So we have only 3 questions now. Question number 15, 16 and 17. So only 3 questions left. And after this, we'll start electricity has been done. So after this, we'll start the next chapter. What is the next chapter? I think it's magnetic effect of current. So magnetic effect. We will start that lesson immediately after we are done with this lesson. So this will be the last video on this lesson, chapter 11, electricity. So it's been an amazing journey. I will say it's been an amazing journey. I don't remember when we started, and today see, okay, today see we're ending this. So that is how life is, okay. We don't know how we started. We started with nervousness, we started with shy, and we started with full of timidness, but you know, life works out, okay. Just think of how you met your best friend, to whom you are sharing everything and to whom you click along. Just think, okay, give a moment to how you met your best friend. Think on that. Think on that. I want you to think on that. How you met him, how you met her, and today look at you, how close you are. But once upon a time, okay, you were strangers, but you met, and today you are bonding very well. So like that, okay, life happens, okay. So let's start. So the first thing that we do is we always read the question. So let's read the question together and let's solve this problem. So question number 15 reads, 2 lamps, one rated 100 watt at 220 voltage and the other 60 watt at 220 volt are connected in parallel. To electric main supply, what current is drawn from the line if the supply voltage is 220 volt? But at the same time, okay, over smart is also a limit. So just because one is too excited, one cannot be over smart. So time to cool down, okay, because nobody likes over smart. Even I myself, I don't like over smart. So I should also know a balance, okay, because everything there is a balance, okay. So let's not be over smart. So we have read the question, and on reading the question we come to know that there are 2 lamps. So there are 2 lamps, let's first try to understand the question. Okay, so there are two lamps, so let me just draw a lamp. So basically this is how a lamp is. So we have two lamps, lamp 1 and lamp 2. So two lamps rated 100 watt. So 100 watt, one of the lamp, let's say this is lamp 1, so power 1 is 100 watt for lamp 1. This is lamp 1, okay, lamp 1, and this is lamp 2. And the potential difference, the V for lamp 1 is 220 voltage. These things are given to us, okay, and the other 60 watt. So the power rating for lamp 2 is 60 watt, and the potential difference is same. So V1 is 220, V2 also is 220 voltage, are connected in parallel. So these two lamps are to be connected in parallel. So let's draw a parallel combination for these two lamps. So parallel, this is lamp, one of the lamp, and lamps have the filament in them. If you're wondering how come sir is drawing resistance for the lamp, is because the lamps have in them the filament, the tungsten filament, which gives them light. So it is not wrong to draw resistance, okay? So they have resistance, so I don't need to draw this also. Actually, I don't need to draw this. You have to understand that this resistance represents the lamp, the resistor present in the lamp, okay? So we have plus, minus, plus, minus, plus, minus, and this is the circuit diagram. We have lamp 1 and we have lamp 2. This is lamp 1, this is lamp 2. Remember this. This is the lamp 1, this is the lamp 2. So the two lamps are connected in parallel combination. Now the question reads, what current is drawn from the line if the supply voltage is 220 voltage? Now this part is the tricky part, my dear students. The question is asking what current is drawn from the line if the supply voltage is 220 voltage. What is the question asking? The question is asking what is the current flowing through the system. Okay, what is the current drawn from the line? Means what is the current flowing through the system? So how do we answer this question? It's very easy. My dear students, look at the combination. If I ask you what is the combination, the combination is parallel combination. This is in parallel combination. Now try to remember the discussion that which we had when we were discussing about series combination and parallel combination. There are two things which I have told you to remember for when you are learning combination, which is the quantity which remains constant and the quantity which gets divided. So in parallel combination, let me ask you, what remains constant? What remains constant in parallel combination? In parallel combination, what remains constant? It is the potential difference. So the quantity which remains constant in parallel combination is potential difference. That means the potential difference across this point and this point, okay, the potential difference for the system remains constant. Then the next question is, if potential difference remains constant, then which quantity gets divided? So the next question is, which quantity gets divided? So the quantity which gets divided. Anybody who can answer? Please, who will answer this question? Which quantity gets divided in parallel combination? Yes, correct, absolutely correct. It is current. So current gets divided. So remember, in parallel combination, current gets divided. Okay, from where will current get divided? From where will current get divided? See, from here the wire gets divided in two parts. One part here and one part here. So the current will, whatever current came here, after from this point it will get divided in two parts, and then later on they will join again, and then the current will flow throughout the system. So current gets divided because there are two paths available for current. So current gets distributed, current gets divided, and later on they join again. From this point again, the overall current will flow through the system. So this is what happens in parallel combination. So the question is asking what current is drawn from the line if the supply voltage is 220 volt. So the voltage for the system is 220 volt, and we have to find the current. We have to find I. Okay, we have to find I. So current I flows here, and till here it will be I, but after this current I will be divided in two parts, I1 and I2. So I1 current will flow from this path, and I2 current will flow from this path, and again they will join, okay, and give you the same, okay, current for the system I. Remember this. So the question is asking us to find I. So can we say this, my dear student? Pay attention to this one, because this is the concept. Can we say this? Since they want us to find I, can we say this? Okay, can we do this? Can we find I1, I1, I2, add them and get I? Can we do this? Do you agree with this statement? We will find I1 and I2. We'll find I1 and I2, add them, and we'll get I. Is that correct? Can this be done? Yes, it can be done. Okay, so we'll find I1, I2, and add them. If we add I1 and I2, that is the current throughout the system. That is the current flowing from here to the system. Okay, well, when the current flows through I1, I2, okay, current flowing at I1 and I2 will be different, but again they'll join and give I. So which will be the current flowing through the line? So the current flowing through this line, can be found by adding I1 plus I2. So remember, my dear students, the concept is here. The current flowing across this path is different. The current flowing across this path is different. So if you want to find the current flowing through the line, just add I1 and I2. Find the current flowing in I1, find the current flowing in I2, add them, and you'll get the current flowing through I. We'll find the current flowing through the line. Alright, so let's solve this together. So what we will do is, we'll write given, because that's what we are supposed to do. We have to always write whatever informations are given to us. So on reading the question, we get P1, which is, what is P1? 100 watt. Then V1 also we get, V1 is 220 volt. Then we also get P2. P2 is how much? 60 watt. And we have V2, which is again 220 volt. Now we know in parallel combination, I forgot to fill up the ink also, so let me change my marker. We know in parallel combination, current gets divided. Therefore net current, let's call it net current, which means capital I. So net current, which is the current flowing through the line, okay, can be found by finding the current flowing through this path and the current flowing through this path, which will be net current is equal to I1 plus I2. All right, so now let's find I1 and let's find I2. So let's find I1. So for I1, let's write finding I1. Finding I1. For I1, we'll be using these details. Okay, for I1 we'll be using these details. So P1, which is 100 watt, and V1, which is 220 volt. The formula we'll be using, current formula, which is I is equal to P1 by V1. So I, to find the current, we have this formula is now P is equal to VI. So from here you get the formula of I, which is I is equal to P by V. So to find I1, it will be P1 divided by V1. So I1 power 1 100 and V1 220. Cut. So 2 ones are 2, 2 ones are 2, 2 fives are 10. So I1 is equal to how much? 5 by 11. Keep it like this. Okay, this is our I1. Then let's find I2 now. So finding I2. To find I2, we'll use these values. So we have P2, which is 60 watt, and we have V2, which is 220 volt. The formula for current remains the same. So we know it's power divided by voltage. So I2, we're finding I2. I2 is equal to P2 by V2. So I2 is equal to power 2, which is 60, potential difference is 220, cut the 0, and simplify again by 2. So 2 ones are 2, 2 ones are 2, 2 threes are 6. So I2 is equal to 3 by 11. So we have I1 value 5 by 11 and I2 value which is 3 by 11. Now let's find the net current. So let's find the net current, which we will get by adding I1 and I2. By adding I1 and I2, we'll get the net current. So let's get ourselves the net current. So net current I is equal to I1 plus I2. So I is equal to I1 is 5 by 11 and I2 is how much? 3 by 11. LCM will give us 11. So I is equal to, this is 11 and upside 5, again 3. So I is equal to 5 plus 3, 5, 6, 7 and 8. So 8 divided by 11. So what you have to do is divide 8 by 11. So 11 gets to divide 8. If you divide 8 by 11, what you get? You get the answer I is equal to 0.73. So since this is current that we are finding, the unit for current is A, which is ampere. So this is ampere. This is it, my dear students. This is the answer. So 0.73 is the answer. So what we can write? Therefore, the current drawn from the supply line is equal to 0.73 ampere. So this is the answer for question number 15. So now I will erase this. I hope you are copying it down. Okay, copy down, and I will erase this and then write the next question and we'll solve the next question together. So question number 16 has been written. Let's read the question, understand the question, and let's solve the question together. Question number 16 reads, which uses more energy, a 250 watt TV set in 1 hour or a 1200 watt toaster in 10 minutes? So having read the question, we come to know that the question talks about two devices, a TV and a toaster. So let's start solving. So let us draw a small diagram here, because with diagrams and figure it's easier to understand. So I don't know how to draw the exact TV, but just for understanding we can draw like this. Let this be the TV, because the question talks about a TV, and on this end let me just draw a toaster, which again may not resemble an original toaster, but just for illustration to make it easier, we draw ourselves a makeshift toaster. And let's break the page and solve separately. The question is asking to find which uses more energy. Is it the TV which uses more energy, or is it the toaster which uses more energy? Which I cannot tell right now. Okay, which we cannot tell right now until unless we calculate the energy. Okay, but before that, let's write down whatever things are given to us. So we write given, and then what do we write? Whatever information the question has provided, we write them. So for the TV, what information did the question provide to us? It has provided us with the power, which is 250 watt. Also the time of usage is given to us, which is 1 hour. Then for the toaster, power is given to us, which is 1200 watt, and the time of usage is also given to us, which is 10 minutes. Okay, just let me write minutes. It's understood, isn't it? Now I want your attention on this time. Okay, look at the unit of time. Here it is in hour and here it is in minutes, not same. So we have to make them same. So we will convert both the time into seconds. So 1 hour, if we convert it into seconds, how many seconds are there in 1 hour? How many? Anyone? How many seconds are there in 1 hour? It's 3600 seconds. All right. Then how do we convert? So how many minutes are there in how many seconds, sorry, not minutes, how many seconds are there in 10 minutes? How do we find this? Just multiply 10 with 60. Okay, then you get the answer, which is 600 seconds. Okay, so now we have the power, time. Now what we need is, we are ready to find the energy, so for which we need a formula. So we need a formula. Do we have a formula for energy? Yes, we have a formula for energy. Okay, we have to make the formula, okay, for energy, because there is a formula. The formula for energy will be derived from this formula of power. Power is equal to energy by time. This is the formula for power. So from this formula, we have to devise the formula. We have to extract the formula for energy. So what we do is we go for cross multiplication. So this becomes energy, and this is P into time. So the formula for power is, the formula for energy is power multiplied to time. So we know, what do we know? We know that energy is equal to P into T. So energy is equal to, power is how much? 250, and time is 3600. What we do? We multiply. On multiplying, you will get 9 lakhs joules. All right, 5 zeros are there. Now let's go here. So again we write, we know, because we actually know, isn't it, the formula of energy, which is power multiplied to time. So energy is equal to, power value here is 1200, and we multiply with time, which is 600. So on multiplying this, what do we get? We get 7,20,000 joules. So by now you understood, by now from this answer itself, you can tell which uses more energy. This is, what is the value? The value is 9 lakhs here, and the value is 7,20,000. So which uses more energy? Undoubtedly this uses more energy. It is the TV set which uses more energy. All right, but the answer, we still have one or more 2 steps to do. Okay, but by now it's very clear. From this answer itself, it is very clear that it is the TV set which uses more energy, because this is 9 lakhs and this is 7,20,000. This value is more. Okay, now what we can do is, instead of writing such a big number, we can write 9 into 10 to the power 5 joules. So this is the answer, and let's do the same thing for this also. Okay, so what do we do? So this can be written, like this: 7.2 into 10 to the power 5 joules. Okay, so this is the answer. So this is 9 into 10 to the power 5 joules. This is 7.2 into 10 to the power 5 joules. 7.5 10.5. Same. Look at this value. This is 9 and this is 7.2. It is very clear which value is bigger. 9 is bigger. So the answer is therefore energy consumed by the TV set is more. This is the answer. So question number 16 is done. Now I will erase this and write question number 17, and we'll solve question number 17 together. So question number 17 has been written. Let's read the question, understand the question, and let's try to solve the question together. Question number 17 reads: an electric heater of resistance 8 ohm draws 15 amperes from the serviceman's 2 hours. This should be for 2 hours. Calculate the rate at which heat is developed in the heater. So the question talks about a heater. Let's just draw a figure like this. Let's say this is the heater, and the resistance of the heater is given to us, which is 8 ohms, and also the current, which is 15 amperes. So whatever information has been given to us in the question, we will be writing it here. So given what information is given to us, we are given the resistance of the heater, which is 8 ohms, and also the current flowing through the heater, which is how much? 15 amperes. And even the time has been mentioned, which is 2 hours. Now what does the question want us to do? The question wants us to calculate the rate at which heat is developed in the heater. The rate at which heat is developed in the heater. So let's write it down. Rate at which heat is developed. Now, rate at which heat is developed, my dear students, remember, rate at which heat is developed is nothing but power. This is a very important, this is the most crucial element in the answer. So let me just box it. So this is very important. Let's put some star marks here to highlight that this is important. Okay, this question, okay, in this question you are to find power. You are to find power only. The question wants you to calculate the rate at which heat is developed in the heater, which basically means you are supposed to find power. So you will have to know the formula of power. So the available formulas of power are P is equal to, we have V square by R. We have used this formula in the previous questions. Then we have P is equal to I square R. Then we also have P is equal to E by T, which we have been using in the last two questions, question number 16 and 15. We have been using this formula of power, energy consumed by time taken. So for this very question, which formula of power should we use? That depends on the values given to us. So looking at the values given to us, which is the most ideal formula? This seems to be the most ideal formula. So let's pick this formula of power, which is I square R. So I square is given to us 15. So 15 square, R value is 8. So 15 square means 15 times 15, which is 225 into 8. So 225 into 8 will give us 1800. 1800 watt. So this is the answer. We actually got the answer. Okay, this is the answer, my dear students. This is the answer. So to write the concluding statement, we will write the rate at which heat is developed in the heater. Therefore, the rate at which heat is developed in the heater is equal to 1800 watts. So this, my dear students, is the answer for question number 17, which happens to be the last numerical on the exercise. And with this, my dear students, we will close the chapter of electricity and start the next exciting chapter, which is magnetism. So that will be the next chapter which I'll be uploading. So the video lessons, you can expect them soon. Okay, I'll be uploading them immediately after this video. So like I said at the beginning, there was a delay for which I apologize to you. I beg your pardon that I took such a long gap, but like I said, okay, it is always at the back of my mind. I am also ever restless, and it eats my mind also that I have to upload. So I am committed and I'm gonna carry this till the end. So this is something which I love, and I love doing this. So I need a lot of prayers from you, my dear students. Okay, continue praying for me and remember me in your prayers, so that I am given good health, and at the same time this joy and this confidence, I should say, and also at the same time this energy which I should bring, so that I'm able to effectively reach to you all, my dear students. So With this note, I'll take my leave and I'll see you again in the next video.